A step two question then, 2022 question number 4. It's a really lovely question about mod functions. I really like mod functions. If I was taking a step paper, it's the kind of questions I would look for. We did a lot of practice of them in Temua, and the idea is the same. We're going to be using this functional definition of a mod function, whereby we just say, okay, what this function does is, if the input is bigger than 0, you just keep the input exactly the same. And if the input is less than 0, the output is now minus that number. So for example, if the input is 6, the output is just 6 because 6 is bigger than 0. And if the input is minus 6, the output is minus 6, which is 6 because minus 6 is less than 0. And we'll be using this a lot in this video here. So okay, the first one is this function here, and when x is less than 0, this is going to become a minus x based on the definition of the mod. And this one here, it doesn't matter whether you have a more complicated function as the input here, you're still just going to times it by minus 1. So x minus 5 is less than 0 when x is less than 0. Because it's like minus 1 minus 5 is minus 6. So we're going to times that by minus 1 to make it become a 5 minus x. You put that all down. So this has become a minus x, this has become a 5 minus x, this has become a plus 1, and it becomes, or still a plus 1, I guess, and it becomes minus 4, so that's the first part done. Then you consider between 0 and 5. Of course, there x is positive, so it's just going to be an x. This is still negative, because when x is less than 5, something less than 5 minus 5 is negative, so you times it by minus 1, becomes a 5 minus x. You just put that all in, and you end up with 2x minus 4, which is what they wanted. And the last one, they're both positive here, because of course x is positive, but of course x minus 5 is also positive, so it just stays as an x minus 5. And we end up with this, which is this. And we can sketch this as well. When x is negative, we just got the function minus 4, so that's a flat line at minus 4. Between 0 and 5, it's 2x minus 4, so it starts at minus 4 and has a positive gradient. And then when we're at 5, it has a horizontal line at 6. Verify at 5 itself. This is equal to 6, and so it carries on from the same place that it left off from, and we can put those numbers there, I guess, and that will be done. Now we'll get to do the whole thing backwards, which is fantastic. So now they're giving us the piecewise function. It says use the modulus signs to write it. So instead of doing this, getting this, it's asking, here's this thing, get this thing out of it. Now, what I first thought was that, okay, well, the only real difference here is that you carried on with x's on the end bits. So basically, if you were to set up something similar to this, which of course should be the idea, I think these x's aren't allowed to match exactly, because down here, essentially one of them is going to be acting as, or down here, I guess both of them are acting as negative, and then here only one of them is. And because you've still got this minus here, this minus x, you can't just be cancelling these x's out anymore. So I reckoned you needed to maybe put a 2 in one of them to maybe make like when this is negative and when this is negative, you have minus x plus 2x, which doesn't quite work. So maybe I should have thought this through immediately. There are, of course, is a better way of doing this, but I just thought trial and error would be the quickest way. Of course, A would have to be 10 if this had any hope of being correct, which I'm pretty sure it doesn't, because of course this needs to change behavior at 5. So we still need that to be a 10. I then realized that, of course, this just doesn't work, because when they're both positive, you get x minus 2x. Which just doesn't work at all to make a positive x. So I figured that needs to be a 3, but now you've messed everything up. So it was at that point I realized the 2 needs to go there, because if the 2 is here, then when you're back in this case and they're both negative, you get minus 2x minus x, which is a minus x, and that was what I was going for when I was thinking of putting the 2 somewhere to try and make that happen. But it just works much better here. This needs to be a 5, of course, to make it change behavior at 5. And then, of course, you can just say b is 5, and you end up b is 5, of course, because it needs to cancel this 5 at points, and it also needs to add up to it to make it 10. And just by some trial and error, you can very quickly get to this. There is, of course, a proper way of doing that, which we will do in the last part, because the last part's a bit more complicated, and trial and error doesn't really work. But I can't stress enough, this took me about 20 seconds to run all the way through in my head, so I just figured that was the more efficient strategy in that question. Anyway, now it says sketch the graph with equation this, where h is this bit more complicated looking function, but the idea is the same, right? Firstly, we need to identify when this inside of the mod is positive and negative, so that we can use that functional definition of the mod. Well, it's a quadratic, right? So it's going to be roots either side, or answers either side of the root. So critical points 0 and 5. Bigger than 0 is either side. So less than 0, more than 5 is where this is positive. So basically, we're going to have, when x is less than 0, obviously these two terms never change because there's no mod function. This is going to be a minus x. And this here is not going to change because when x is less than 0, that there is positive. So that there is just going to stay exactly as it is. When you clean that up, you get this, which factorizes this. So it's a quadratic with roots at 0 and 1. So it looks a bit like this. However, we are only drawing this quadratic in the negative space. So we only want this part of it up there. Okay, and then we move on to the next bit. So now we move on to what happens between 0 and 5. So again, this doesn't change ever. That's a positive now. So we're going to just be taking away 4x. And this is negative between 0 and 5. That thing is negative because we're between the critical values. So that whole thing is going to get times by -1. And when we clean that up, we're going to end up with this, which is fantastic. Just draw a line across at 0, which is just looking like this. And that'll be that good. And then when x is bigger than 5, again, never changes this. This is still just a positive x. That's now positive again. So we just keep it. And then we put it all together and we end up with this, which factorizes to this. Roots at 0 and 5. So it's a much bigger quadratic. 5, notice, was the place where this function ended. So roots there and there. But again, we only want to draw this function when x is bigger than 5 or equal to 5. And so it looks a bit like this. And that'll be our sketch all done. Good. The last part then. So what I decided to do was write h of x. We discovered those three things as we were going along. So I wrote it as a piecewise bit because what I wanted to do, of course, is now that I'm supposed to write this in mods, I'm supposed to write it a bit like this. I want to be doing some comparing, right? I want to be thinking, okay, well, how did this get to this? How similar is that to this? How can I then reverse engineer that? Now, I figured that the key thing here was this term here, because I kind of know how step questions work at this point. They fed that to me, this idea of a mod function that changes behavior twice at 0 and at 5, which this one does as well. It's got the same points where it changes behavior. So I reckon this is something that just has to be in my formula. I'm also just going to keep these ideas here because why not? It might not work, but I'm going to just keep them anyway. So I've written them in a different order, I guess. But I'm just going to figure that's probably what this wants me to do. I also very quickly realize I have to tag a plus e on the end because there's constants here. So I mean, if I didn't have the e there, none of this has anything to do with constants. So I'm never getting a 50. So this was my first guess. Just put a bunch of random letters in front and see if you can solve for them later, I guess. Very quickly, you realize this doesn't work, though. And the reason it doesn't work is because you can test it if you want when you put x is less than 0. Of course, this changes behavior. This doesn't. Remember, that one doesn't change behavior at x is less than 0. But the problem is you've got nothing here to cancel with the e, right? You're trying to make this thing equal to 10x. But that would mean e would have to be 0 because there's nothing else here that's a constant. But of course, if e is 0, then when you get to this stage, you've got nothing that's going to give you a 50. So this just doesn't work at all. So we've got to now think through, okay, well, this didn't really work. Like this didn't, I can't get rid of the e. I can't have the e because then it's 0. So what do I do here? And the key here is to think, well, okay, I need to change behavior at x is less than 0, between 0 and 5, and greater than 0, except this one does all of that for you. This one changes behavior between 0 and between these two, and it also changes behavior between those two, right? So actually, I don't really need this one to be changing at 0, do I? Because this one does that for me. So what I could do instead is I could make this one change behavior at 5, because that's still good enough. I'm still changing behavior at all the different points. But of course, this is fantastic now because this gives me a minus 5a, in other words, another constant, which could then start working with the e to try and get these constants to match later. So let's run with this. Again, it still might not work, but it seems like a good strategy. So let's just try it now. We've got lots of time. X is less than 0. This is going to change behavior, so it becomes a 5 minus x. This isn't, as we discussed, and neither of these do, of course, because they're not modulus functions. So we get this. So this, yeah, sure. And then we set that equals 10x. And we say, okay, well, let's just compare coefficients. We need the constants, which are 5a plus e to be 0. We need the x's, which are this, and this d5 thing to be 10, which I put there, sorry. And we need the squares to be, which is c plus d, to be 0. So that's helpful. We've got lots of constants here, but I'm kind of just hoping for the best. And this gives me some ideas that maybe it will work quite well because I can now see that c is equal to minus d, which essentially gets rid of a constant for me, although I'm not going to use that straight away. Let's just look at the second line. So when x is between 0 and 5, that's still negative, and that's also negative now. So we have got a change from the previous line, which is good. That's supposed to equal 2x squared. So this time, 5a plus c, which is still a constant, needs to be 0 again. So again, no new information there, which is disappointing. But c minus d now has to be 2, very helpful. And the last one, which is still this. oh no, it's not, it's got a plus d at the end, hasn't it, is 0. And that's very helpful too, because if we look at these two things here, I think we can immediately see that c is going to have to be 1 and d is going to have to be -1. So that's those two solved and out the way. Fantastic. We could put that result into here if we wanted to, although I'm actually not going to yet. I'm just going to move on to the third one and just do it all at the end. So on to the third one, when x is bigger than 5. That's positive, and that's back to being positive as well, because that was bigger than the critical value. So okay, we do the coefficients one more time. We've got, this time the constants are now making 50, which is fantastic. Those two equations look like they'll just solve for a and e for me. We get c plus d is 0 again, so that's fine. It's not a contradiction or anything, so that's great. And now looking at the x's, we have a plus b minus 5d equals 0. And now, of course, looking at these two, we can now solve for a and e by doing this one, take away this one maybe. We get 10a equals -50, so a is -5, which of course -25 plus c equals 0 means e is 25. And then finally we have d, we have a. Let's just go to this equation here. We have -5 plus b plus 5d because of the -1 equals 0, so b is 0 as well. So fantastic. I think we have all of the constants. So that's a, b, c, d, and e. So let's put them all into here, and we get this. And now it says explicitly verifying your formula is correct. I guess what that means is I just need to do what I did in the very first part, which is just say, okay, when x is less than 0, this one changes behavior, this one doesn't. I get this, which simplifies to this. Fantastic. When x is between 5 and 0, all video I've been very fast and loose with the strict inequalities. It doesn't really matter. Maybe I should have verified that these two things match at the same point, like when x is 0, 10x is equal to 2x squared, I should have maybe said, just to say that these two things meet up. Although, do I even need to say that? Do they care that they meet up? No, they probably don't, because it's not a graph, is it? Anyway, we get this, which is this, which is this, and I think that's all they wanted me to do. Thanks for watching, and I'll see you next time.